Welcome to springlib.
Hello, so today we're going to be drawing a distribution curve for carbonic acid, hydrogen bicarbonate, and carbonate. So let's give each of these a color. And now let's first, when we're drawing a distribution curve, let's look at the pKa's. So the first Ka, so the Ka of carbonic acid is 4.2 times 10 to the negative 7. So then the pK, which is the negative log of 4.2 times 10 to the negative 7, the pKa will be 6.38. Now let's take a look at the second Ka, the Ka of bicarbonate. So that pKa is 4.8 times 10 to the negative 11. So then the second pKa will be 10.32. So now let's create the axes. So the x-axis will be the pH. So we'll go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. And then there will be the mole fraction. I'll label half and a whole. So this is fraction. So mole fraction. And so the first pKa is when there will be equal amounts of the carbonic acid and bicarbonate. If you want to confirm that, you can just check the Henderson-Hasselbalch equation. So at pH 6.4 around is when the carbonic acid and bicarbonate will be in equal concentrations. And then at 10.3 is when the bicarbonate and carbonate will be in equal concentrations. So let's start with the carbonic acid. So at low pH, it comprises like the entirety. And then it goes down and it tapers off to nothing. Now let's take a look at bicarbonate. So first it starts off as nothing. Then as the pH grows larger, it'll start to get higher. And then it becomes dominant. But then The bicarbonate will start to become carbonate as it becomes more basic. So it crosses here and then it tapers off to nothing. And now let's take a look at the carbonate. So at very low pH, it is dominant and it comprises the entirety. Then, as the pH gets lower, it'll be converted to bicarbonate, and then it'll taper off to nothing. So there we go. And we see that at any pH, there are only two forms of carbonic acid, bicarbonate or carbonate that are in any appreciable concentration.